Determining the appropriate wire size for a service mast involves several key considerations to ensure safety and code compliance. In this scenario, with a duplex having two 200 amp services and utilizing a 2-gang meter base, the primary factor influencing the minimum wire size is the total calculated load. It's crucial to understand that the ampacity of the service entrance conductors, including those in the service mast, must be sufficient to carry the anticipated load. The National Electrical Code, or NEC, provides the guidelines and tables necessary for calculating these loads and selecting the appropriate wire size. Firstly, determine the total calculated load for each dwelling unit. This involves assessing the connected loads, including lighting, receptacles, appliances, and any fixed equipment. The NEC provides specific demand factors that can be applied to these loads, recognizing that not all connected loads will operate simultaneously at their maximum rated current. These demand factors vary based on the type of load and the number of appliances or circuits. Secondly, after calculating the demand load for each dwelling unit, sum these loads to determine the total load in the 2-gang meter base. This total load will dictate the minimum ampacity required for the service entrance conductors. Thirdly, once the required ampacity is known, consult NEC Table 310.16 to determine the appropriate wire size for the service mast conductors. This table provides ampacity ratings for various conductor types and sizes, considering factors such as insulation temperature rating and installation conditions. It's important to select a conductor with an ampacity equal to or greater than the calculated load. Furthermore, consider the ambient temperature and any adjustment factors that may apply. NEC Section 310.15 addresses ampacity correction factors for ambient temperatures other than 30 degrees Celsius or 86 degrees Fahrenheit. If the service mast is located in an area with high ambient temperatures, the ampacity of the conductors must be derated accordingly. In addition, voltage drop is another important factor to consider when sizing service entrance conductors. Excessive voltage drop can lead to inefficient operation of electrical equipment and appliances. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders and service conductors. To minimize voltage drop, it may be necessary to increase the size of the service mast conductors. When selecting the conductor material, copper and aluminum are the most common choices. Copper has a higher conductivity than aluminum, meaning it can carry more current for a given size. However, aluminum is lighter and less expensive than copper. If using aluminum conductors, it's important to select a larger size than copper to achieve the same ampacity. Ensure that all connections are made with connectors that are rated for use with a specific conductor material. The type of insulation used on the service mast conductors is also important. Common insulation types include THHN, THWN, and XHHW. THHN and THWN are suitable for dry and damp locations, while XHHW is suitable for wet locations. Select an insulation type that is appropriate for the environmental conditions in which the service mast will be installed. The NEC also requires that service entrance conductors be protected from physical damage. This can be achieved by installing the conductors in rigid metal conduit, intermediate metal conduit, or rigid non-metallic conduit. The type of conduit used will depend on the specific installation conditions and local codes. Grounding is another critical aspect of service entrance wiring. The service entrance conductors must be properly grounded to provide a path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electrical shock. The grounding electrode system typically consists of a ground rod, a water pipe electrode, or a concrete encased electrode. The size of the grounding electrode conductor must be in accordance with NEC Table 250.66. Also, consider local amendments. Local jurisdictions may have amendments to the NEC that affect the requirements for service entrance wiring. It's important to consult with the local electrical inspector to ensure compliance with all applicable codes and regulations. Now let's delve into specific conductor sizes based on common scenarios. Note that these are examples and a proper calculation is always necessary. Firstly, if the calculated load for each dwelling unit is 100 amps, the total load on the 2-gang meter base would be 200 amps. In this case, a minimum of 4/0 American wire gauge or AUG copper conductors or 250 kc mil aluminum conductors would be required for the service mast. Secondly, if the calculated load for each dwelling unit is 125 amps, the total load on the 2-gang meter base would be 250 amps. In this case, a minimum of 250 kc mil copper conductors or 350 kc mil aluminum conductors would be required for the service mast. Thirdly, if the calculated load for each dwelling unit is 150 amps, the total load on the 2-gang meter base would be 300 amps. In this case, a minimum of 350 kc mil copper conductors or 500 kc mil aluminum conductors would be required for the service mast. These examples assume that the conductors are insulated with THHN, THWN, or XHHW insulation and are installed in conduit. The ampacity ratings may vary depending on the specific installation conditions. Also remember to verify your local electrical codes and practices. It is also critical to select appropriately rated overcurrent protection devices, such as circuit breakers or fuses, for the service entrance conductors. The overcurrent protection devices must be sized to protect the conductors from overload and short-circuit conditions. The NEC provides specific guidelines for selecting the appropriate overcurrent protection devices. Lastly, ensure proper labeling. All service entrance equipment, including the meter base, service disconnect, and overcurrent protection devices, must be properly labeled to identify their function and rating. This helps to ensure safety and facilitates maintenance and troubleshooting. Selecting the correct wire size for a service mast is a critical task that requires careful consideration of several factors. By following the guidelines and tables provided in the NEC and consulting with a qualified electrician, you can ensure that the service entrance wiring is safe, reliable, and code compliant. The calculations mentioned serve as examples only and should not replace a thorough load calculation and adherence to all applicable electrical codes and regulations. It is always recommended to consult with a qualified electrician to ensure the safety and compliance of any electrical installation. Furthermore, consider the impact of future load growth. Electrical demands tend to increase over time as people add more appliances and electronic devices to their homes. When sizing the service entrance conductors, it's wise to consider the potential for future load growth and select a wire size that can accommodate these increased demand. This can help to avoid the need for costly upgrades in the future. Remember that the information provided is intended for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. The electrical code is updated regularly, and it's important to stay up to date on the latest requirements.